Hello and welcome to today's PIR live event webinar brought to you by Partners in Research Canada. My name is Stacey Joyce and I will be your host. Remember, if you're joining us live, that you can ask questions anytime throughout the webinar by clicking chat in the top left corner of your screen, and make sure you change the to field so that it includes attendees as well as panelists. That way the other classrooms joining us live will be able to see what it is that you are asking. So today's guests are Dr. Andrew Slaughter. He is a visiting professor working with the Global Institute for Water Security at the University of Saskatchewan. And we also have Hayley Carlson, who is the user engagement specialist with the Integrated Modeling Program for Canada at the same Global Institute for Water Security at the University of Saskatchewan. Thank you so much for joining us today. I will turn it over to you both.
Perfect, thank you so much. We'll just share our screen here. And I will hand it off to you, Andrew.
Yeah, thank you. Thank you for the opportunity to present to you. I thought just as an introduction and to allow the participants to understand what we do in terms of our modeling, I'd introduce the water cycle. I'm sure a lot of people watching already know about the water cycle, but I can just introduce it again. So in a very simplistic way, a lot of the modeling we do involves certain aspects of the water cycle. So within the water cycle, you could have evapotranspiration from vegetation such as forests and trees. So we call this evapotranspiration because the trees are drawing water from the earth. And that water is then released through transpiration, and the water vapor enters the atmosphere. And then also we have evaporation from water bodies like the ocean. So you also get water vapor going into the atmosphere, and that water vapor forms clouds. And the clouds eventually lead to precipitation, so either as rainfall or snow. And that water then hits the ground, and some of it infiltrates the ground, and some of it runs off the ground into rivers and lakes. So, and then the cycle begins again. So what we do in the center is to model these different aspects of the water cycle, and we'll show that later. Just to show you what happens to the water that goes into the ground. So some of it goes into the ground directly from the rainfall, so it infiltrates the ground, and then it can be stored under the ground. And some water in the ground is actually really, really old. Some groundwater that is very deep can be thousands of years old. And that you also get water infiltrating the soil from underneath rivers. And a lot of this water eventually emerges again into the surface water through springs. And as I said before, trees take up the water, and that water is then released again into the atmosphere through evapotranspiration. An interesting thing about water on Earth is that the amount of water on Earth has always remained the same. So it has gone through the cycle that I mentioned earlier. And what is really interesting is that for every glass of water you drink, a lot of that water was once part of a dinosaur. So dinosaurs have been drinking that water, and now, millions of years later, we're drinking that water, the same water molecules. Another interesting thing or important thing that, or concept you need to understand is the concept of a catchment. So a catchment is a surface area that feeds a specific water body, a river or a lake. And we all live in a catchment. So everyone lives in a particular surface area that feeds a particular river or a lake. And within a catchment, you might have farms, and cities that use the water from the river, and you'll even have factories that are using the water or polluting the water. And what is important is that how we use water upstream affects people downstream. So if farms are using too much water upstream, that means there's less water for people downstream, or the nature downstream, or farmers downstream. And if factories are polluting the water upstream, it means that people downstream will be affected by the pollution. So very importantly, our climate is rapidly changing at the moment. We're getting increasing frequency of droughts and flooding. So these extreme events are becoming more and more common. So we get things like hurricanes. I'm now going to pass over to Hayley, who's going to talk about some of the impacts of these extreme events. The one is in California.
So some of you may have heard in the news a few years ago about the drought that California was facing. So this is an image of Lake Oroville in California, which is the second largest reservoir in California. On the left-hand side of the picture, that's what the lake normally looks like. And then on the right-hand side of the picture, you can see what the lake looked like after 4 years of drought in California in 2014. And you might ask, why does it matter if California has less water, and why do we really care in Canada? We should care because a lot of our produce in Canada, things like oranges, almonds, and broccoli, come from California. And so when we had a drought situation in California where farmers were struggling to water their crops, we had either less of those crops in Canada, or we had very expensive crops. So your oranges may have costed more that particular season than you were used to paying.
I'm going to come back now and talk about Cape Town. I'm sure everyone's heard about Cape Town. Cape Town is in a very dire situation with their water, and basically their water is running out. They've almost got no more water. So you can see that their reservoirs are almost empty. And people are resorting to collecting water from springs. And thankfully, a lot of them are still running in Cape Town. So there have been campaigns in Cape Town to get people to use less water. And water restrictions have meant that the amount of water people can use has decreased more and more. So it was 100 liters a day earlier in the year and late last year. And now that's even less. So they're predicting that day zero in Cape Town will be by July of this year. Day zero basically means there'll be no more water in the taps. And Cape Town will be the first large city to run completely out of water if day zero happens. And people will have to stand in line to collect 25 liters of water per day. That will be their allocation. And to put that in context, the average Canadian uses about 330 liters a day. So you can just see how little water people will have to make do with because of running out of water. So
what if you turned on the tap one morning and you were going to brush your teeth and then no water came out? And that's the question, is could we have this situation that's happening in Cape Town happen in Canada? So we like to think of ourselves as a country that is abundant in water resources. And I think we tend to take water for granted here in Canada, but we're not immune to water issues. So we already have experienced times where we have too little water. So this is a picture from the Western prairies last summer when we had a very dry growing season. And then of course, British Columbia, Alberta, and Saskatchewan have been so dry in recent years. There's been very publicized forest fires that have happened. We also have times of too much water, and you folks in Eastern Canada will know that. This is a picture from the Grand River flooding right now that has prompted Brantford to declare a state of emergency. And then water quality can also be an issue. So if we experience problems like toxic algae blooms that Regina and Moose Jaw experienced, and that pollutes their water supply, that further limits the amount of water we can actually use for things like brushing our teeth or drinking. So of course, we've mentioned climate change, and Canada is one of the regions in the world that is warming at a faster rate than other places in the world. So we are seeing winters that are starting to warm earlier than normal and be warmer than normal. So a lot of our water in Canada comes from that snowpack, that snow that we accumulate in the winter and then melts in the spring. In Western Canada, that tends to accumulate in the Rocky Mountains. And because Canada is warming, we're having less snow overall, and then also snow that's melting earlier in the season. So this is a picture from Montana, a glacier in Montana. On the left side of the picture, you'll see 1913, that's what the glacier looked like. And you can see how much it has receded in 2012, where there's basically no glacier left. And this particular mountain range in the 20th century, so that was last century, had 150 glaciers recorded, and now that number is down to 25. So we're really losing, that's an example of how we're losing our glaciers in Canada as well. So what does this all mean? Basically, it means that because we have increasing pressures on our water supplies, we have to start making hard decisions about our water. We're facing pressures like, on one hand, in Canada, we're getting a lot more people, and across the world, we're getting a lot more people. We need water for those people. But at the same time, we're experiencing climate change, which is really threatening our water supplies. And that really means that we're going to be having to make choices about our water. So would you be using water, for example, for something like hydropower generation? Or should we put that water instead towards irrigation to grow more crops? We're going to have to be making trade-offs between those different choices we're going to have to make. We also need to save some water for nature. Nature provides us with a lot of course, important goods and services that we need. So things like fish, wetlands can provide a form of flood control. Rivers can clean our water, make the quality more drinkable and easier for us to access. And then we also have things like canoeing, different recreation activities we all use our water for. So it's important to consider, along with our development decisions, how much water we're actually leaving to nature to allow us to continue, or allow nature to continue to provide those goods and services. And that's really what we're looking at the Global Water Futures program here in Saskatoon. And we're also partnered with Waterloo and McMaster University out east. And we're looking at basically building computer models to predict floods and droughts and manage water quality and water supply. And the project that Andrew and I work on is called the Integrated Modeling Program for Canada. And this is our logo that I've shown here. And in it, you can see pictures of all of the concepts we've been discussing. So the blue image with the mountain represents the water cycle. We're looking at computer models to explore the water cycle and impacts to the water cycle. The green with the dam is showing the development decisions that we make with our water every day. The red part of this is looking at decision-making. How can the modeling work and research we're doing here support decision-making around water resources in Canada? And the yellow part of this shows the importance of working with different water users, because that's really important in the work we're doing, which we're going to talk about a little bit later.
Yeah, so within the modeling that we do, we have a lot of different models, but there's two main types that we could talk about, and those are hydrological models and water resources models. And I'm not going to go into very much detail about them, just give a very broad overview. So with hydrological modeling, this you can really relate very strongly to the water cycle that we discussed earlier. So obviously in the water cycle, you can see the role of rainfall. And for our purposes, we could use a climate model to predict rainfall. And that rainfall, along with temperature, that's also predicted by the climate model, would allow us to determine how much evaporation we'd have. And we'd feed that information into a hydrological model. Now, the hydrological model will determine how much rainfall infiltrates the ground and how much is converted to overland flow into rivers and flow into lakes. So the hydrological models will give us information like how much flow we have in our rivers and how much groundwater we have. So that's an overview of hydrological modeling. And the second type of modeling we have are water resources models. So hydrological models give us an idea of the natural flow. So if there were no people on Earth, the hydrological models could tell us how much water there is. But unfortunately, people use a lot of water, and water resources models can help us determine how much water people actually use. So we take the information from the hydrological models, so our flow in our rivers and our groundwater, and we also take information like how much people do we have in our catchment and how much water do they use. And this just wouldn't just be the water that people use, but also water that irrigation uses, water that hydropower uses, water that factories use. So we put that into a water resources model, and the water resources model can tell us information like how much water we should release from a dam to provide water to users downstream, how much water a factory can take out of the river before users downstream have too little water. And so the water resources models allow us to plan for the future, how many factories we can support, how much irrigation we can support, how much water people can use, and also allows us to use water sustainably, and allows sharing of water, equitable sharing of water amongst the different users. So that's an overview of a water resources model.
So to some of you, maybe those models looked a little complicated, and they can be very complicated. It takes lots of time and energy to build these types of hydrological models or water resources models using computer programs. So one of the things we're exploring at the Global Institute here is different creative ways to show the results of models. So this is a map, it's called the Canadian Drought Monitor. It's a program run by Agriculture and Agri-Food Canada, and it essentially shows, it rates drought for different areas of Canada. So you might recall previously when I mentioned that last growing season in Western Canada was very dry. So this particular map shows the results of models that tell us how much precipitation we received, how dry it is. And you can see in southern Saskatchewan there's a red patch, there's some brown. That's showing us that we're in, or Saskatchewan at the time was in periods of extreme drought and severe drought. So this is one way we're exploring more creative ways of showing the results of models and more easily understood ways. So this is another map. This is the US Flood and Drought Monitor, and this is run by Princeton University in the United States. So this is a type of map that you can actually manipulate. So you can use the plus and minus symbols up on the top left corner there to zoom in. You can pick different variables from the right-hand side. You can pick different time zones that you want to look at the information on. So this particular screenshot that I took is precipitation over the United States from February 16th this year. And you can see that where the pink and red is sort of where the most precipitation was falling during that day. And as I said, you can use that plus and minus symbol to zoom in. So if you lived in somewhere like Cincinnati or Pittsburgh, you could zoom in there and see how much precipitation you received. One thing that you might also be interested in is, okay, I don't really want to know how much we received, but how much are we going to receive? What is the forecast saying for the temperature or the precipitation that we're going to receive in whatever area that I'm interested in? So this is a map showing the forecast for March in the United States. And this is a model that's running in the background, and the results are showed in this interactive map here. So you can see in the northern states, we have a darker blue. On average, those states are going to be receiving temperatures ranging in the 0 to 5 degrees Celsius. And then as we go further south in the United States, we're receiving warmer temperatures, of course, between 15 and maybe 22 degrees Celsius. So that's a forecast, an average forecast for United States for March. So this is another interactive tool that we're working on building here at the Institute as well. Sometimes the people we work with aren't really that interested in maps or reports that are really detailed and long and hard to understand. So Some other ways we've used in the past to explore model results and different research that we're doing around water here is to build interactive displays. So this is a display that was built as part of a research project that was done in 3 large river deltas in Western Canada. So the Saskatchewan River Delta, the Peace Athabasca River Delta, and the Slave River Delta. And researchers went into those communities and talked to the people there about what kind of sustainability challenges they were facing, what kinds of things they valued about the water in their deltas. And those people worked with our researchers, and then the researchers partnered with artists who took the results of the research and built an interactive diagram, sort of like what you'd see at a museum, where you can go in and kind of manipulate different parts and look at pictures and different artifacts from the region. And that was a creative way for those people to explore model results, just like the maps are. So one more thing that we really value here is working with different people. Like I said before, it's part of our logo, so it's part of what we do. And of course, you know that different cultures, different groups of people have different needs around water. And so if we make decisions from only one group's point of view, we might not be making decisions that are fair or that work really well for different groups of people. So we like to work with partners across Canada so we can understand different groups of people, how they're using water, how they need to use water, and how we can make more balanced decisions about how to use that water. So one of our main partners is the Government of Canada. We work with different partners in the Government of Canada. We also work with what we call transboundary management groups. So these are groups that manage waters that either are part of 2 different countries or 2 different provinces. So the International Joint Commission there manages water that crosses between Canada and the United States. And the Prairie Provinces Water Board, which is the other logo you see there in Western Canada, manages water that crosses between Alberta, Saskatchewan, and Manitoba. We also work with hydro companies like BC Hydro, Manitoba Hydro. We work with a lot of different provincial governments like the Yukon government, and we work with communities. So this is Cumberland House. It's located in the Saskatchewan River Delta. It's a primarily Indigenous community. They have different types of sustainability challenges around water and different types of cultural relation to water. So we work with them and we try to bring all those different perspectives into the conversation so we can make decisions that are actually going to affect people on the ground in a way that's more fair, more balanced, and considering different perspectives. So I think that's it for our part of the webinar today, but we'll take questions now.
Wonderful. Well, thank you so much for sharing that with us. You can go ahead and click that red stop share button. And I have our first question here is from Ms. Pereira's class. I'm just looking to see if they've told us so far where they are joining from. Yes, they are from Cornell in Toronto. And they have a very simple question that I suspect has a very complicated answer. They are wondering why we even have droughts.
Do you want to take that one, Andrew?
Well, I guess it is a really complicated answer. Obviously, there is a lot of natural variation in rainfall that we have. So droughts are not something we're experiencing only now. Droughts have happened throughout history. But climate change has meant that droughts are becoming more and more common. So it's becoming the new normal, especially in places like Southern Africa, where you used to get a drought once every 20 years. Now it's once every 10 or 5 years. So that natural variation is becoming altered by climate change. And we need to plan for the future, for a different future, and conserve and manage our water resources.
And I'll also mention that even the word drought is a really complicated concept, because drought can mean a shortage of water for agriculture, or it can mean a hydrological drought, or a drought for forest regions. It can be short term, it can be long term, it can be a result of, 5 or so years of below normal precipitation and above normal temperatures, or it can be just contained within a season. So it would be easier probably to answer what was the cause of a particular drought rather than what's the cause of all the droughts. But hopefully that sheds some light on your question.
Yes, I think that does. And it's very interesting to note that these natural occurrences are happening more often now. It's not necessarily something when we think of climate change that you think automatically there's going to be more floods and more droughts. And anyway, the statistics don't lie, so they are becoming more common for sure. We now have a question from Beaverton Public School, and they are wondering if our water, meaning I guess water from Canada, is going to be pipelined down to the United States as they experience more drought.
I think you better answer that.
Very interesting question. I think I've heard a lot of people talking about is water sort of the next global conflict that we're going to be facing. And you've certainly already seen instances, I think in BC, of trade disputes between different companies from the United States wanting water from Canada. So, you certainly could see agreements around that. And these are this falls into what we were talking about around decision making. When we make decisions about how we're going to be using our water, is part of that decision making going to involve actually providing water to the United States? That might be something that is a real issue that comes up in the future. I don't think we're quite there yet, but if things keep going along the trajectory they are, we could see that emerge as a real issue in the future.
Great. And a question now from the grade 9s and 10s at Assumption College in Brantford. Wondering how will the flood there affect drought levels in the area? Will it help to prevent drought?
Well, my understanding of the flood there on the Grand River was it's due to sort of this prolonged period of extensive cold and then this rapid warm period, and there was a lot of ice. There was an ice jam that sort of led to flooding. So the flood itself, I don't think will have a long-term impact on drought in the region, but the Eastern Canada in general has been experiencing much more wet periods lately than is the normal sort of for the area. So I don't think that this particular flooding incident will have any long-term impacts on drought in the region. It would be more probably wise to look at precipitation over the entire winter season and how that continues into spring and the rest of the growing season as we move forward.
Right. And do you think that in Canada we should be expecting drought to be occurring on the level that they're experiencing in South Africa now, to the point where our demand for water will lead us to a day zero, or maybe in certain regions of Canada and not others? What do you think?
I think Canada is facing slightly different issues. We have definitely some parts of Canada that are water stressed, and other parts where there is certainly enough water. So in certain parts of Alberta, is that right? Certain parts of Alberta are already water stressed because of excessive use of water for irrigation. So I think the risk is variable across Canada in terms of too little water.
Yeah, and in Western Canada, the previous century, we've experienced a pretty mild, if you look at the paleoclimate record from Western Canada, there's a lot of variation. We had very wet periods, very dry periods, and this past century has been a very mild period of time if you look at the history of the region. So we're not even, in Saskatchewan and Alberta and Manitoba, we're not even experiencing the variability these regions have experienced previously in the past, let alone that variability combined with the impacts of climate change. That could exacerbate our water issues so much that we actually are facing something like that. But I think that's still quite a ways in the future. And as Andrew says, we're facing different management challenges here now.
Right. And we now have a question coming from a class in Alberta, wondering if you work with any groups in particular in Alberta. They were watching your map and didn't see any particular ones highlighted there.
Yeah, so I only chose a few people on our map just so it wasn't overpopulated, but we actually have 170 partners across Canada. So we're working with quite a few people. In Alberta, we're working with a lot of different people. Alberta Environment in particular, we're working on they have a, you may know, they have a water resources management tool there called the WRMM, and that's how they look at how water resources are allocated to different sectors in Alberta. So we're working with that group. We're working with a group up in Edmonton as well, and we're working with different communities as well. So people like farmers, because as Andrew said, Southern Alberta in particular is facing some very hard decisions around allocating water in dry periods of time because there is so much irrigation in Southern Alberta. So definitely on our radar.
Right. And we're just about out of time here, so I do want to squeeze in one more question for each of you to take a turn answering. Essentially, you have different roles, but you're working within the same field, sort of, or at least working around the same global and Canadian issues. Can you tell us a bit about your path to where you are now, in case students are listening to all of this and thinking, hey, this is something I might want to get into? And maybe let us know how you got into this space.
Sure. Do you want to go first, Andrew?
Okay. So at university, I was really interested in water, and I first studied marine biology. But then after that, I thought it would be really great to work in a field that's water related, but that has more importance for people and people's needs. And that really, at the moment, is freshwater. So I moved into freshwater research, and that's eventually how I landed up here in Saskatoon.
I had a very frustrating science teacher in high school who liked to come in and tell stories about how we're overfishing the oceans and things like that. So I got really kind of angry and then went and did an environmental sciences degree. And then I realized that even though we're doing good science around things like water and climate change, it doesn't necessarily lead to good decisions about how to manage our resources. So that led me to a policy degree because I realized I'm sort of like Andrew, that it's really where people are making the decisions and where people are using the resources where we run into the issues. So that led me to this institute where I'm doing work with people, essentially doing user engagement work. So
right. And it's interesting to hear that both of your paths started kind of pointed in this broad direction, but it seems like you took a little bit of a turn partway through and changed up what you were doing. I seem to hear that time and again from our guests. But I'm going to leave it off there, that we're already a little bit over time. Thank you so much for joining us today and presenting those issues to us and presenting sort of what's being done and answering our questions today.
No problem. Thanks for having us.
So next week on PIR Live event, we have a webinar for Pink Shirt Day, and we have another webinar discussing astrophysics to kick off our month of March. So more information on these webinars and other educational programming is available on our website at pirweb.org. Thanks so much for tuning in, everyone, and have a great day.